Here we go. Okay, today's lesson is A104, Solving Systems of Equations by Elimination, Part 2. What's our objective, class? Get ready?
Solving systems of equations by elimination, Part 2.
Very good. Good choral response. Thank you. So we've already learned the elimination method. We haven't learned Part 2. So here's what's new in Part 2. We're going to have two equations that normally we want that elimination pair. Remember, same variable, same coefficient, but one's positive, one's negative. But today, it's not going to look like that. We're going to have to manipulate it to make it look like an elimination pair. Okay, so let me show you what I mean. Plus 4y and minus 4y, that's an elimination pair. What?
Elimination pair.
An elimination pair, same variable, same coefficient, one's positive and one's negative. And if I were to add these two equations, I could slash through because positive 4 minus 4 is 0. That's why I can eliminate them at equals 0. But what if I don't have an elimination pair? What if my two equations, like they're all nicely lined up, you know, and I've got a 1 here and a 1 here, but if I were to add these, I'd get 2y. That didn't eliminate, because one of them needs to be negative. And see, and these are different coefficients. That's a 1 and that's a 2. But these are so close. If only I could make one of them negative. Can I? Can I change one of the equations? Can I use balanced operations? Could I manipulate one of the equations so that I do have a negative? Lucas?
Couldn't you times one of them by -1?
Could I times one of them by -1? Yes, I could. Let's just for fun, let's do the top one. It wouldn't matter which one. If I keep a balanced equation, I have to times both the left side of the equal sign and the right side of the equal sign by the same thing so that it's still balanced. And then I get negative. Actually, you need to go get a drink. Alex, you can get a drink if you need to. So I can distribute my negative to here. I'm going to distribute it to here. That becomes negative. I'm going to distribute that to here, and that becomes negative. So let me clean it so it looks a little bit better. So what I did, basically, I just took everything and I times it by -1. It made it negative, negative, negative. So now I can stack and add. I have negative x plus 2x. There's a 1 right there. Negative 1 plus 2 would be positive 1x. Negative 1y plus 1y eliminates. There's my elimination pair. Perfect. Negative 5 plus 7 is 2. And in one step, I just found out that x equals 2. That's why most of my students, after they learn all the methods, they love elimination method. So I like to clean up my original and then solve for the other variable. How do I solve for my other variable? AJ?
I just take the top and say 5 minus x, which is equals
Is you that's coughing? You need a drink?
No, I'm fine.
I got a cough drop in my top
I'm good.
file cabinet.
I'm good. I got one in my pocket.
Okay. Okay, so we got 2 and 3. And if we wanted to check it, we already know 2 plus 3 is 5. We could double the 2, that's 4. Plus 3, that's 7. We know we did it right. Okay, good. Let's do another one. So this one is 2x plus 5y equals 7. Negative x minus 3y equals -1. Dang it, I don't have an elimination pair. Remember, I need same variable. Got it. Same coefficient. I don't have the same coefficient here. I do have a positive and a negative. I do have a positive and a negative. What can I do?
Myra, should I push one maybe? So like, just make one equation, like 2y negative x, just x. Divide y and 3y, like x plus 2y equals 6.
Okay, as long as whatever we do, we have to do it to everything. So if I choose to times by 2, I have to times everything by the 2.
So I just mean that, can't we just add all those equations up into one equation? And then
If I do, I'm going to have a whole bunch of x's and y's. What I want to do before I add, I have to make sure something will eliminate. Lucas?
you can times the bottom one by 2.
Oh, okay. I like his idea. Let's try it out. So we're going to distribute the 2 across. That gives me negative 2 times x, negative 6y, and negative 2. I basically doubled everything. Everything has to be doubled. I'm going to rewrite my top equation on top. so that I can stack and add, because what Lucas gave us was an elimination pair. One's positive, one's negative, same coefficient. We're going to slash right through them. Use a different color so we can see it a little bit better. Okay, that gives me 5 minus 6 is negative 1y equals 5. And in one step, I just figured out what y is. Because I don't want negative y, I want positive y. So I could times both sides by negative. I get y equals negative 5. How do I solve for x? Now that I know y. Stacia.
You put it in the equation.
Okay, pick one for me. Which one? Top or bottom? Top. So we're going to put y equals negative 5 right there. So I'm going to solve it out. Let me solve it over here. 2x plus 5 times negative 5 equals 7. That's 2x minus 25 equals 7. We're going to add 25. Add 25. 2x equals 32. How do I solve for x now? Spencer?
You divide both sides by 2.
Very good. Alec, you were super fast on that, which is
16.
16. I got two solutions, 16 and negative 5. If I wanted to check it, I could substitute them back into both and make sure it's right. Jacob?
Do you necessarily have to show that you divided it by both sides on both sides, or can you just do all the elimination at the top when you're when you're isolating x, okay, and then can't you just add it up, write it underneath, divide by whatever you need to, and then do you have to put 2x equals 32?
Well, we're learning. Yes, you do. Once you get into high school and this becomes more intuitive, you can skip a couple steps. Okay, that's a good question. All right, here we go. Now we're not going to solve just for exercise sake. We're going to practice. What do we do to manipulate an equation? So I want you to actually manipulate it so that we have an elimination pair. Here's our first task. On your paper, write down the two equations: negative 2x minus 7y equals 7. Your second equation, x plus 3y equals 1. Decide what would you do to manipulate one of the equations so that you have an elimination pair. As soon as you've made your manipulation, put your pencil up. Mrs. Belknap and I will walk around and check you. We're going to do this 3 times. Okay, back to me. All right, I saw a lot of mistakes here. I'm a little bit concerned, so we're going to go over it real careful. I want these numbers to match, but it would be a little complicated to make a match. This would be easier to make them match. I could make this a 2. If I could make that a 2, I would have an eliminating pair. Same coefficient. What do they need it to have? Get ready?
Same coefficient.
And they need different signs. What?
Different signs.
Different signs. So if I can make that, and then I learned before, I could just multiply both sides by a 2, and then I could get a 2 there. Okay, I saw some of you trying some weird things. I don't know, maybe you weren't listening before. Okay, so we're going to multiply. So we get a 2 there. We're going to multiply 2 times that one. We're going to multiply 2 times that one. So let's rewrite it. We get 2x plus 6y equals negative 2. Now I have an eliminating pair. Okay, just these two right there. If I add them together, I get 0x, which is just 0. All right, makes sense? Give me a nod if it makes sense. Okay, we don't even need to solve it. I just make sure you guys know how to find the elimination pair. Let's do another one. The next one, whoops, is right here in the middle. How would I get an elimination pair out of these two? What would I multiply by to get an elimination pair? Okay, write it on your papers. Do it real quick. I give you 20 seconds. It's a real quick one. 20 seconds. Okay, Alex, what did you multiply by?
I multiplied by 3.
Cool, bottom equation? So, can I just squeeze that in there? 3, which put here? Good. Some of you forgot that one. At least 2 of you did. You did these 2 and you forgot about this one. I saw another student that put a 9 there. So be careful. You're just timesing 3, 3, and 3. And it happens since we had a 1, 1, 1 there. That's why it's an easy 3, 3, 3. Did anybody pick something other than 3? Hiram, what'd you do?
I did 4.
Wait, so 4 could work?
Because the y is in the cross out.
That would also work. I want you to consider this, okay? If I had a triangle, and it was a 3, 4, 5 triangle, and I'm going to times the whole thing by 4, my new triangle, okay, is going to be 12, 16, 20. You have to times, if I'm gonna times something by 4, I gotta times everything by 4. I can't just pick 2 of them and not times the third one by 4. So when you're multiplying through, you have to times all 3 parts with your coefficient. You're doubling it, tripling it, quadrupling it. Okay, the last equation for you guys, our task, I need 100% in here. I gotta have every one of you 100% to make sure you understand how to make an elimination pair. What do I do to manipulate one of these to make an elimination pair? Put your pencil up when you've got it. Okay, let's check you. Dakota, what'd you get?
Negative x10 minus 50 equals
Say that one more time.
negative 10x minus 50y
Equals negative 10?
Yes.
Excellent. Raise your hand if you got this. I watched her and I think most of you had or were about to get it. 100%. Very good. Good. So we just multiplied both sides by 10. I want to stretch your mind a little further. We chose to make this equation bigger, but could we have chosen to make this equation 1/10 smaller?
Yes.
I could have. So I want you to start expanding because these problems are simple now, but next year you're going to have to do a few more steps to manipulate things, and it could be something like this. It could be cutting an equation in half by a third. You could be dividing something out, and that would go right? And then also we have 1, 5, and 7. That would be easy to work with too. All right. We have a stand-up break for 20 seconds, and I'll give you your practice problems. Go.